Welcome everyone to our webinar titled Managed KubeDB, Seamlessly Deploy and Manage Database using KubeDB in Kubernetes. This is Pulakkanti Bhumik. I am a senior software engineer at AppsCode, and I have Russell Hossain with me. Russell, can you please introduce yourself?
Yeah, I am Russell Hossain, currently working as a software engineer at AppsCode.
Thank you. So we are both working on this Managed KubeDB project. Let's see our table of content. So at first we are talking about a buzzword called DBaaS, that is database as a service, and then we will look into some DBaaS offerings, and then we will discuss about our KubeDB current offerings, that is as a product KubeDB offer at this moment. And then we will discuss that what Managed KubeDB come up with the new features on top of our KubeDB. Then we will discuss about the details workflow of our Managed KubeDB, that how it works. And then we have a demo. And after that, we have a question and answer session. In the meantime, you can ask your question in the Zoom chat. Then we can, in the question and answer session, we try to answer your questions. Now let's talk about the DBaaS. In 2023, you might have heard a lot of managed service and also a lot of buzzwords like platform as a service, infrastructure as a service, and database as a service, that is DBaaS, is also a kind of a buzzword at this moment. And it means that you don't have to when actually you try to set up a database, you have to worry about a lot of stuff, that is physical hardware, installing your database software, the database configuration, database performance, monitoring stuff, a lot of things. But when you try to get a managed database solution, then it will actually do everything for you. That is, a database provider will actually set up the infrastructure for you, operate, scale database, and upgrade the database, monitoring the database for you, and everything for you. So in our demo part, so we actually show that our Managed KubeDB, how our Managed KubeDB work. For that, we need a Kubernetes cluster. We actually spin up a Kubernetes cluster from scratch and install a database on it. So as we are using AWS to deploy our database. So I think now I am going to Russell so that we can spin up a Kubernetes cluster from scratch for our demo part. So Russell, can you please take over and create a database cluster in Kubernetes for us?
Okay, thank you. Can I share my screen there?
Sure. I think I can stop share.
Now we have our we are in our Byte Builders console page, and we can see here we have our new create and import flow. So we can create a cluster from this import flow. Let's hit the import button and select our provider as AWS and hit the next. Okay, I have already created a credential, AWS cred named as. So I am selected this credential. If you don't have any credential, you can create a credential from this create credential button, and I'm clicking the next. Here we have two options. Select cluster. If you choose the select cluster, you can import a cluster from that exist that are currently in your provider, or otherwise you can create a cluster, a new cluster from the scratch. So first we have to provide the necessary information like cluster name. We are creating a cluster name as webinar. Okay, we are selecting the region. We can select the region, such as we are now we select the region US is 2, then machine type, and then Kubernetes version of your cluster, then the create. Okay. So this is our create cluster options, we can see the logs here, so it will take a bit time. In the meanwhile, we can discuss about our Managed KubeDB project. Okay, Pulak, can you
Yeah,
cover from
so
here?
yeah, sure. Thank you, Russell. So he's creating a cluster for us for the demo purpose. Now let's talk about the benefits of DBaaS. That is why you need a managed database solution in 2023. At the first point, that is obviously the reduced infrastructure cost, because when you actually try to set up a database, you have a serious, a massive cost upfront. You have to buy your infrastructure and then set up your database. But when you go with a database provider or a managed database provider, then you don't have to worry about the upfront cost, because you can take a specific machine or select a specific machine that work for you, and then you can also choose for pay as you go option. And in that case, you just have to pay that what you have used for your infrastructure. And the second one is obviously improves scalability and flexibility. Because when you go with a a managed database provider, you have flexibility to choose SQL, NoSQL database like KubeDB have provided, MySQL, Postgres, and also MongoDB, Redis for caching. And for scalability, let's say when you have to, when you try to manage your own database, then you have to worry about your scalability. You need to scale manually. But for when you go with the provider, you can take you should not worry about this part, because provider will scale your database when the database load is up. So the database provider will provide you improved scalability and flexibility. And then obviously the high availability and disaster recovery. Most of the database provider come up with a disaster recovery solution. That is in our case, we have Stash to back up your database. And it is obviously database provider will make sure that your database will highly available in terms of high traffic as well. And it will also make sure that the database will back up periodically. So in case of a disaster scenario, it can protect your data. And then the improved security. So especially the security part is very tedious, because when you try to set up your own database, then you have to worry about the security part. You have to implement the firewall, and you have to set up the access management. But when you go with a database provider or a managed database solution, you don't have to worry about the security part, because most of the database providers will provide you a better security and a firewall, so that there is no unwanted access of your database. And also your database transaction and other stuffs are also happen in a secured way. And there is I think this is a key benefit of DBaaS, that is the reduced maintenance and management overhead. Because when you actually set up your own database managed infrastructure, then you have a serious overhead of managing things. You have to make sure that your machine is up and running, your database is up and running. If there is any updated version of the database, you have to update that manually. You have to make sure that the database is scaling up for a high traffic. So, but when you go with a managed database solution, then you don't have to worry about those management overhead, because then you are actually offloading those overhead to the database provider. Because database provider will take care of any kind of management overhead. It will scale up on high traffic and everything, and do everything that the management task. And finally, there is a faster time to market, because when you are choosing a managed database provider, then you can only focus on your strategic or business logic part. You don't have to worry about the other stuff, so it can help you to go to the market really faster. So now let's talk about our current KubeDB offering. And the first, we will talk about our KubeDB comes with the lower administrative burden, because KubeDB, you don't have to worry about that is the administrative burden, because KubeDB comes with a lot of database, as I spoke earlier, that KubeDB comes with Elasticsearch, MongoDB, MySQL, Postgres, Redis, those. So you can get all the database in one place, so you don't have to worry about those administrative part, and KubeDB actually comes with that lower administrative burden. And then native Kubernetes support. To run our KubeDB, you just need a Kubernetes cluster. So it can be anywhere, that is any cloud provider Kubernetes, or a bare metal Kubernetes, or your own private cluster, because then you can just install our KubeDB and can use it natively in your Kubernetes cluster. And then come to the performance part. KubeDB is highly performant database in terms of that. KubeDB using PVC to provision provision our database and keep your data. So that, and it using the existing storage class. So by maintaining that, it can maintain a high performance even on the high traffic as well. And then the availability and durability. And obviously, we have a stash we talked about earlier, that for the backup and recovery. So in terms of any disaster scenario, you can set up a periodic backup. So the stash will take the backup in an incremental way. So, and you can keep those backup data in your cloud S3 or GCS or other like bucket. Then, and it also support a incremental backup. That is, you have to only the stash will only backup the part that is the newly added. So then it will also reduce the cost of your cloud bucket size. So, and then the manageability. KubeDB obviously comes with better manageability, because it has Prometheus support. So you can use our default exporter. And we have currently have support for Grafana dashboard, so you can watch your data from your Grafana dashboard. In your Grafana dashboard, we collect data like I/O activities, CPU storage, memories. So you can see all the I/O activities, or how many disk size is there. Then you can take actions accordingly. So that's it. And then the final cost effectiveness, because KubeDB is currently come up with definitely a lower cost than others database provider. If you go with the cloud, you might have to pay maybe a high cost. So if you are using KubeDB, then you can get a lot of database options, that is NoSQL, SQL, caching, Redis for caching, and that in a one place, and that is definitely a cost-effective matter. And finally, security. And KubeDB comes up with a highly runs database in a highly secured way. You can use TLS for the database transactions and everything. So that even our backups data, you can encrypt our backup data as well. So by this way, you can maintain a high secured way and access control, so that the database are only accessible to the person you are allowed. Now talk about our managed KubeDB offering. That the things I talk about the KubeDB offering. There's currently KubeDB come up with lots of good stuff. But what currently you have to do, you have to install a helm chart in your provision Kubernetes cluster. Because then you have to, you can use KubeDB. Then you have to also manage manage your database, also make sure that your database is up and running. Also make sure the upgrade path. Let's say you want to upgrade, so you have to do things manually, and we are working heavily on this to for a better user experience of KubeDB. That's our main motivation to build a new version, or let's say next generation product of KubeDB, which we are calling Managed KubeDB. And then in Managed KubeDB, we are giving you a easy provisioning path of your database, even for the cluster creation. That you are already shown is sometimes ago, that we are provisioning a cluster from scratch using our from our UI also. So that is, then you can we actually install our database on it. So Managed KubeDB come up with a very easy provisioning path. So you can also provision the database as well as your cluster using our Managed KubeDB solution. And then the offload operational headache. This is a key point I have to mention, because when currently now, if you go with manage your own database or even KubeDB, you have to you have to take care about the operational headache, because let's say you have to upgrade a database, or you have to make sure that database pod is up and running, and those things. But when you comes with the Managed KubeDB, it will have the recommendation engine. So then the recommendation engine will notify you about the upgrade path. Or also you have to make sure or that your database is up and running. This headache to us. So we are actually take those headache that your database will 24/7 operational and running. So then you can you don't have to worry about those management and operational tasks at all. And then currently with our Managed KubeDB, we are working with most of the popular clouds. Currently we are working with AWS, GCP, and Azure support. Try to add these supports in our Managed KubeDB, but in future we will also add our other popular clouds. So currently, you can already see in our UI that there is some options for our cloud providers. So currently, we are heavily working on these three: AWS, GCP, Azure. But also in future, we are also extending our pool of clouds providers. So you can, from anywhere, you can provision or manage your databases. Then backup and recovery. Obviously, as the Managed KubeDB provider, we will try work. We are also working on the backup and recovery part. We are working on auto backup, so that you just have to tell that you want backup for your database, and maybe the period of backup, periodic backup. Then we will do everything for you by our product called Stash. So you don't have to worry about your database backup and recovery section. Then the security and compliance. Then definitely we are doing our things in a highly secured and compliance maintained way. We are currently as we are using public cloud, let's say it's AWS, GCP, and Azure. We are trying to take full advantage of that cloud provider firewall, so that you can make sure, and we are also we can make sure that your data will be highly secured, and you can also maintain the access control of the database. If you can tell us the IP whitelisting or some other stuff, so that we can we will configure your database accordingly. Then you can only access your database from that instance. So we will try to make sure that your database is highly secured in our Managed KubeDB project. And then no vendor lock-in, because you already see that we are using your cloud. So that means we are giving the proper platform, so you can use your own cloud. So you literally owner of your own data. So I think this is the most important thing. So there is no vendor lock-in in our Managed KubeDB project. And now let's talk about the Managed KubeDB workflow. So let's say at first you have you are provisioning a database cluster using our byte builders console. Then let's say currently by default we are provision a cluster with 3 nodes. In future we are also configuring it so that you can say the size of your database cluster. And after that if you have to give a you will give a basic configuration. And in the existing cluster, we are also installing. We will also install the necessary stuffs like KubeDB, Stash, and other stuffs that we need for our to make sure your database is up and running. For those stuffs are also installed in this node. And when the database the actual cluster is come up, then you can tell us the database configuration. And the database configuration you will have to say the minimum stuffs. Let's say the database you are selecting database as MongoDB, and let's say you want a 3 replica set of containing 3 replica, and you want to run this as a production environment. So we are taking care of this. Then we actually provision a 3 more nodes and install a MongoDB replica in other 3 nodes. So that your database pods are not affected by various problems that is happening in the cloud, like noisy neighbor problem, so that your pod can use the best of the host machine. And then we will finally then to access part, then we will finally tell you in our UI the host names of the database, also maybe the auth secrets, then so that you can use it from your application cluster or connect from your application to the database. So that's our managed database workflow in a bit high level. So now we want to go a bit deeper, so that we have currently 2 mode. That is, if your application is, let's say you want to deploy your database in AWS, but your application is now outside of AWS, so you want to access the database from outside of the AWS networking backbone. So we have also this feature, so that you can access your application, access the database from your application in a highly secured way. Then maybe you will tell us about the IP whitelisting part, that which IPs you are trying to access, so you can maintain the access control of that part. So we are trying to take the full leverage of the AWS networking firewall rules, like you can say the security group or route table. So we'll configure those networking rules in a way that only you can access your database from your specified application of your according to your given IPs. So in this case, our database instance will have a public IP, and it will attach to the route table. So then you can access the database from outside the AWS networking backbone in a highly secured way. And now let's see a scenario when you don't want to expose your DB in the public cloud. Then let's say you have also the application cluster also running in AWS. So you want to stay in the AWS networking backbone in a highly secure way. So in this case, maybe let's say let's talk about a scenario. Let's say you have a DB cluster that is running on a VPC1 with a different CIDR range. And you have an application cluster, let's say Kubernetes, another Kubernetes cluster that is in a different VPC, and you want to connect your application with the database to be inside in the AWS cluster, to be inside in the AWS network. So in this case, we are maintaining that by using peering connection. So in most of the cloud, there are 2 VPCs, so we can connect to the 2 VPCs with peering connections. So then you can privately access your instances from other VPC. In this case, you have to make sure that the VPCs are you trying to connect are from different IP CIDR range. That's the only thing. In this case, that your overall database network traffic will stay inside the cloud networking backbone and will not expose to the open internet. So you can make sure in this way that your DB is highly secured and compliance. You can maintain your compliance as well. So now let's jump into the demo. We have Russell here today. So Russell will take care of the demo part. So Russell, can you please share your screen?
Okay. The cluster we have created will take some time to provision and get ready. So we have a different cluster. We have set up a different cluster so that it keeps provisioning. Okay. So when we have our cluster ready, the cluster will be imported to our console, and here we will see the cluster that is newly provisioned. Like this, we have previously we have created a demo cluster. So in this cluster, let's see, it's keep loading. Okay. In this cluster, we are having some feature set. Every feature set that will contain some features in it. We have the Op Center core features, backup and recovery feature set, sorry, and our database feature set. So in this database feature set, we have the KubeDB install. These features will be installed in our import flow. So you, as a user, you don't have to worry about this. So currently we are having 3 nodes. We can see here these nodes are private nodes. So these are assigned private IPs. So we can install a database in this cluster. So let's try to install a Helm chart. Okay. Let's name the let's create a MongoDB database and name the database as MGDB and create it in a demo namespace. So here we can see our Helm chart that will be installed. So Helm install. Okay. Sorry. Okay. Sorry, I haven't export the keep config here. So export keep config desktop webinar. Okay. So let's check our nodes. kubectl get nodes dash a. Here you can see we have 3 nodes that are ready. So let's watch for export. Yeah, I have already exported here, I guess. Yeah. So let's watch the nodes here. Keeps okay. kubectl get mongodb -a. Let's watch for the mongodb. Okay, if now if we install the helm install, it should create a database for us. Currently this part is we are working on it, and probably within a few time this part will be automated, and you can install you can create a database within a few clicks from your UI. Okay, I guess it is creating. The data as we specified in our Helm chart, the MongoDB will create a new we will create a new database, and we will provision it to our new node. So we will also create a node for this database. So it's provisioning. Let's check the ports here. ctl get ports -a -n -n demo. Okay, it is pending now because the node is creating. Okay, here we can see the node here. The node is not ready. If the once the node is ready, then our db pod will provision in that node. Okay, it will take a few time to provision the database. In the meanwhile, we can check here. Okay, so let's open our MongoDB Compass to check the connectivity of our. Again, we want this database to be public so that we can access from the outside of the cluster. So if you check the IPs here, kubectl watch. Okay, we can see here the previous 3 nodes that we have created earlier is don't have any external IP, and the new node is ready and it has a external IP, that is public IP. Okay, now the MongoDB pod should be provisioned in that new our newly provisioned node. You can keep it in watch. Okay, our MongoDB is running and we have our new node. So we can check our external DNS, so we can get the external IP here. ctl get external DNS in MongoDB YML. We have the IP address of our new node. Okay, this is the URL of our database. So if we give the URL to our MongoDB Compass and try to connect it, okay, it will get an authentication error because of our auth. So let's give the auth privately. Okay, get secret Okay. Conol password. Okay. Then it should connect. Okay. Now I have connected the MongoDB Compass to our cluster. As you can see here, our connection info, we have the host IP similar as the our uh, our database URL. Sorry, second one, I guess. This one, right? Yeah, because because it has the public IP in it. Okay, in this section now we can see that we have our some default databases here, and the templates, I guess. Okay. So now we can access this database from outside the cluster. We can also we are working on the private accessing the database in privately, so that in the AWS ecosystem, you can stay in the ecosystem and privately access your database from one account. Okay. Then okay, let's see what is right. Now the cluster is provisioned here, so we can go to the import cluster. This cluster is the cluster we have created the first time, so it usually takes a time. Then let's go to the import cluster section. So once we have this page, we can see our feature sets here. So if we enable the database feature set, it will automatically select the KubeDB option and KubeDB feature. You can also enable the monitoring security part, but for the simplicity, we are okay. Let's now import this cluster. So once you hit the import button, then you will probably see this window that will show how to that necessary stuff that is installing. Okay. It will also take a bit time, but not so much, about 3 to 5 minutes or maybe less. So yeah, then once you have the you have this window, you have this import flow finished, then you will see your newly created cluster in the console. So yeah, I think that's
I think in the meantime, the cluster will be imported. I can add some little details here. That currently you are watching a window that actually we are watching the live log from our cluster. That is, we are installing some necessary stuffs for the managed KubeDB server that you are watching. That we are installing Flux, and we will also installing some other stuffs that you are watching live logs. And the previous window, we are trying to create our cluster. That from there you will also see the live logs. We are heavily working on this, so that you can see, or you can see the every stuffs that are doing on your clusters. So we are trying to be transparent here. So the things we are installing in your cluster, you can see the live logs as well. And in in the failure scenario in let's say in our KubeDB provisioning in your cluster, if there is a if it is failed, you can also then come to know it from the log and also see the why it is failed. Then you can also if it is let's say bad configuration or let's say limit in your AWS or let's say some IP is limited in your AWS maybe in some zones. So then you can come to know it from the logs. So you can take necessary steps accordingly, and then you can import in your then you can deploy the DBs. So currently we are working the DB UI. So that today we are showing using our using the Helm chart, and because our console is supported installing Helm chart, we are heavily working on this. So in the near future, you have a very smooth flow of cluster provisioning cluster and DB installation, and also you can use that database privately inside the backbone networking backbone of AWS or any cloud, or in case if you are trying to access it publicly. Today we have already showed the demo. And to more clarify that, today in the demo part we actually showed the last part first, that is the installing database and using that database from publicly exposed database. We have a you are also noticing that we are giving you a static domain for the host name of the DB, because you know that the node IP we don't rely on the node IPs. So if there is a node failure and new node come up, then you can assure that then the IP the static host name will be same. So that's it. I think we are very close about importing cluster. So the flow will be you will provision your Kubernetes clusters from scratch, and then you can import it to our system. Then you will have a similar experience. Then you have a UI. From UI you can provision let's say MongoDB or something. I think our database provision is successful. Russell, can you please go to the cluster details? Yeah. So it is loading. Yeah. So let's say you have our there is already 3 node installed and using privately. So then we are working on a UI so that you can install the Helm chart that we are installing manually from the terminal from the UI, and you can install the database privately in a production grade in your cluster. So I think that's it from us today. Thank you, everyone. Let's jump into the QA part. So, is there any questions? I think.
I have a question to follow.
Sure.
That is, when you provision a new database like a MongoDB node, so does it install the Kubernetes component on this node?
Can you please elaborate a bit?
In a Kubernetes node, I can see that there are some Kubernetes components, some like etcd or something like Kube API server, or the Kubernetes components or the CNI plugins.
Yeah. Actually, when we provision our main Kubernetes cluster, it will come up with those CNI tools or let's say API server installed. So when we actually provision database here in a production gateway, because we want that the database node doesn't suffer for any noisy neighbor problem. So to make sure that we actually intentionally come up with a new node, and the node actually join with the existing cluster. So the node has the necessary component like KubeDB, like kubelet and container runtime installed in the process, and we are using cluster API. So those things are very faster. To that we can see that a node is come up with maybe couple of minutes and joining in our cluster, and our database come get ready. So I think that's it.
Yeah, thank you.
Thank you for the questions. So I think, is there no more questions? So if you are interested about our Managed KubeDB project or product, then please ping us. You can mail us at hello@appscode.com. We are available in Twitter at KubeDB. You can also visit our kubedb.com and in our GitHub organization, that is github.com/KubeDB. Thank you for your participation and joining for our in today's webinar. Thank you, everyone.